Alright, so we are going to demonstrate the fact that the sum of the exterior angles in a convex polygon is equal to 360 degrees. So first let me just write down the text here so that we don't forget. So the sum of the exterior angles in a convex polygon is 360 degrees. So it's right here. Don't forget. Just to make things easy, I don't need the axis. Also, let's remove the axis. And let's keep the algebra view and the input view, or the input bar, on the interface of the GeoGebra. And just to make things easier too, when we draw our convex polygon, I'm going to use regular polygons. But it should work for any convex polygon for that matter. So we say, so if we start with a regular polygon, say with 5 vertices, so let's have a pentagon. Now, in order to show that the sum of the exterior angles in a convex polygon is 360 degrees, we need to draw our exterior angles first. So which means to say that I need to extend the sides of the polygon. So 1, 2, 3, 4, and then 5. All right. And remember how we define a an exterior angle. It consists of one side of the polygon and the extended side of the other side of the polygon. And now we need to measure each of these exterior angles right here. And in order to do that, we need 3 points. So we have 1 and 2. And then we have this and this side. So we have this and that side, this side and that side, and then we have this side and that side. Alright, so now we have our 3 points. We can label our angle. So to label our angle, we choose our 3 points. So we start with, say, F, A, B. That's one exterior angle. And then you have G, B, C. That's the other angle. Then you have H, C, D. And then you have I, D, and E. And then finally you have I, E, A. Alright. So this is one set of exterior angles. So let's move the angle so that it's clear when we do some dragging later in our demonstration. So I need to move this right here and this one right here. So notice that if you take the sum of the exterior angles, it should equal to 360 degrees. That's why I say the sum of the exterior angles in a convex polygon. In this case, it's a pentagon. It's equal to 360 degrees. So let's verify that. So we have our alpha plus beta plus angle C, which is gamma, plus angle D, and then plus epsilon, which is our E. And then we press equal. So notice that here, the sum of these angles, 5 exterior angles, is equal to 360 degrees. Now, so how does that work visually? So as I said, what we do is we choose one of the points on one of the vertices of your figure. So in this case, one of the vertices on our pentagon, and then we move it inward toward the center of the pentagon. See what happens. So when they converge to one single point right here, there we go. So that gives you 360 degrees. See what happens. So this 72 right here, there should actually be a 72 right there. So there's like 5 of them. 1, 2, 3, 4, 5. That's why we say that the sum of the exterior angles, in this case, in our pentagon, is equal to 360 degrees. And so it should be true. And then of course you can always go back and say, so if you zoom out, then this is what you get. You get the original figure. So let's verify again for another polygon. So this time, let's see. So I don't need my axis. So this time, let's have like an octagon, like an 8-sided polygon. So I have 1, 2, and so let's have an octagon 8. All right. So we have this one. I don't need this point right here. So let me just get rid of this. I do need to move this figure. And then again, we set up our exterior angles. So if we have 1, A to B, B to C, C to D, D to E, E to F, F to G, G to H, and then H to A. And then what you do next is you measure one set of exterior angles. So like you measure the exterior angle right here, so for angle A, and then one for angle B, and then one for angle C, one for angle D, one for angle E, one for angle F, and one for angle G, and one for angle H. So that's one set of exterior angles. Notice that in any polygon, there are two sets of exterior angles. So, but we just need one set. And in this case, we want to show that the sum of the exterior angles in an octagon is also equal to 360 degrees. So remember how we did our first problem involving the pentagon. So we choose one of the points here, and then we move it inward toward the center of the polygon and see what happens. As you move farther and farther, you can imagine like as you move farther and farther away from the figure, eventually it's equal to 360 degrees. So these are the exterior angles 1, 2, 3, 4, 5, 6, 7, 8. So notice that here the sum of the angles, the sum of the exterior angles is equal to 360 degrees. That's how we show that, at least that's how we picture or provide a picture proof that the sum of the exterior angles in a polygon is equal to 360 degrees.